Hello and welcome to this video. In this video, we will discuss what is PCA, Principal Component Analysis, and how we work with it. PCA is a very straightforward approach where we try to reduce the features that we have. It is mainly a clustering algorithm approach, but it is also used in supervised learning to reduce the feature size. We can reduce the features and use this data to give it as an input to our model. Now, principal component analysis is a technique for reducing the dimensions that we have in the dataset, increase the interpretability, but at the same time minimizing the information loss. That means it does not allow to lose a lot of information, even though when we are reducing the features. It does so by creating an uncorrelation variable that successively maximize the variance. Basically, if I talk about on a generic level, it simply create another dimension and put all the plots over this. The shadow of the plots goes over this, and this new shadow becomes our new values. This is how it is basically creating an uncorrelated new variable which can be used later. Now, PC component analysis is a satisfactional procedure where we can get a data in an array format which has reduced dimensionality, but this does not guarantee that you will always get a better accuracy over it. We will also see a practical approach to do this and see if reducing feature is actually giving us a better accuracy or not, because it is said that dimension reduction will improve the simplicity of the model, and it in a result always give a better accuracy, but it doesn't give all the time a good accuracy. It is dependent excessively on the data and the learning process of the model. Important points that we can plot multi-dimension plot a dimension in 2D, but the moment we have 3D or 4D, it is not practical. What PC really do, it make multi-dimensional to be plotted in a 2D line that reduce the number of features, and we find the center point, a center line in between to work get the work done. We detect the most important feature from the clusters that we have, calculate the average of each plot that we have, and that average became the center of origin next time. So if I give you a simple example on this, suppose we have features, two features, and we want say third features too. So these three features are basically controlled. We are not going to work on the third feature right now. Suppose we have plots here and here, we have plots here and here. Okay, we find the average area of these two, the center point of these two, create a new line. Okay, create a new location from which we create a new line. This is on the line actually. It is goes from the line, and this feature became new feature which has this average plotted on this. Now if we have a third dimension or fourth dimension, it just keep creating the perpendicular line over this, and the center point of this line actually became the zeroth location. So this line basically gets shifted at the origin, and this became our new position, and this new position get another perpendicular for each feature. Okay, so same scenario repeats itself, and we do all the plotting within the 2D and get new features and new values. Basically, this line gets fitted into the points. So if we have points, like this, okay, it try to find the best fit line in between, which help us to get the clarity. This is our best fit at this position, and this coordinate on the best fit line is exactly what is used as the final coordinate to give you out. Now it pick a random line and fit it between the best fit line as LR in view in LR, and now the next line start perpendicular to the second in 2D that I have already explained. And important features are measured as how close they are to the x and y axis and the origin that we have. Now two line covers the highest variation are selected as the most important feature, and line coordinate as our last coordinate that we get as a result. That's how PCA works. Now again, it might not make much sense just by reading the theory. So I always prefer to show you the diagram of the things. So I give you the example of coding, how PC really works, and I will explain you how the practically approach is going to work on. So guys, simple logic is that if we have two features, we plot those two features. Okay, we plot the values for those two features. We find the values and we plot those values. Suppose these are my values that I'm plotting. Okay, and these are my values that I've plotted. It do a simple approach. What it does, it find the best fit line, which can start from anywhere. It can start from anywhere. It moves the line and try to find the best fit position, which has the least amount of error from this point. This line has the least error from this point, and then what it does, it find the median point. Now how this line is actually getting plotted initially, we find the average of each point. So we find the average position of each point, and that becomes our new coordinate position. And this average location is usually get in the center position. So if you have this as a center, this became our origin, and this origin is later used. Now the center position basically create another perpendicular line, and the second PCA is found here. So this is the core of PCA. Basically, you can think of it. It finds the center position of each plot, and that center position coordinate became the result of our plot, and that is how it avoid losing a lot of information, but it reduced the feature for sure. So let's move to the coding part. To save time, I'm taking a dataset which is having basic feature of 8, and I'm trying to reduce the feature of this. We will not talk about what the data and what machine learning model we are creating and all those things, because it is not really required. But we will talk about mainly the PCA technique that we are going to implement. I'm assuming you already have the basic knowledge of machine learning, and you already know the describe info part, what this data is about, and I'm expecting that you know the dropping and the handling the age. It means the null values. But let me discuss this in a fast fashion, and the PC part is where I want to take time. So we have this data. We are taking the info. We are checking the columns. We are dropping the columns which are not required, and we have this data at the end. What I want to do, I'm checking each feature with each other. So survive and sex, survive and p class, survive and the parch, and I'm comparing these values and how much values we have for each category. After comparing these values, what I did, I simply use a normal data set and normal project. So guys, I simply move forward and did a normal without PCA technique. I just used random forest classifier, check the accuracy, and I got an accuracy of 82. So this is where I have not used anything. I have just split the data, fit it, and use RFC model to predict it and check the accuracy. I'm getting an 82 accuracy, which is very good. The aim is, if we use PCA, does this change? So what I did, I simply took the same dataset that we have in the clean form. There is no category and no null value we have. This is the main data, which will directly give to the machine learning model. Now, this is where I start using the PCA part. I use decomposition, PCA import. I'm using the same model, same accuracy metrics and everything. I move forward. I did simple for loop here. I have created an empty dictionary, and that I'm using the range from 2 to shape of the model, shape of the data set, which is 9 in this case. And I'm adding 1 plus here. If you remove this 1 plus, it will go till 8. 9 is not required because by default at this moment only we have only 9 features, 3 and 3 and 3. It has only 9 features only. So having 9 features is saying that we are doing the same thing. So I'm trying to compare if we have different PCA values, does it affect, does it change the project that we are creating? Does it change the accuracy that we are having? So let's see that and how it is going to impact. Guys, I'm splitting the data X in a target value with the size 30. Random state is 0, and I'm writing a for loop which will do the process. I am fitting my PCA every time from the range 2 to 9, and I'm giving the split again. Guys, again I'm splitting because splitting has to be changed every time, because the shape of the data is changing every time. Because we reduce the PCA, so we will have different data sets. So I'm using this data set and I'm having different features every time. I am giving these features to random forest. I'm fitting it as you can see in the next line, and then I'm predicting it. I predict the text part. I get the accuracy in by test PCA, and I'm printing the accuracy with the model name. So I have printed that PCA with PCA 3 is 69. You can see when I have just 2 and 3 features, With 2, I have the least amount. With 3, I have 69. With 4 PC, I'm getting 70. With 5, I'm getting 75, which is a decent score. And with 6 also, I'm getting PC. So if I want 75 accuracy, I would prefer in five features, and that will be a good amount. If I go further, I can observe that 7 and 8 are also having the same amount. So I can pick 7 features too. And on going 9, I'm getting 80% accuracy. So it is clear that if we have 7 or 8 features, if we reduce feature 2 or 3 features, we can get almost same accuracy as the complete data set. This can be very fluctuating if we have 80, 90 columns in the data set. Now, moving forward, what I did next is I compare the value. I compare the value of the PC that I got and checking if it is actually true. So now testing my R&D here. I've given PCA 8, okay, and taking take 8 component, I'm fitting and transforming. I again splitted it, again fit it in the model, again predicted it, and checking the accuracy here. I got an accuracy of 83.9, which is almost 84%. It indicates that using a PCA technique, getting a correct PCA value can increase your accuracy to 1 or 2 points, which is a great deal. After 75, every point matters a lot. I hope this PC implementation makes sense, and I hope it was helpful to get you the clarity over the PCA part. This is PCA technique. Again, a lot of in-depth theory and a lot of in-depth knowledge is required, which we will cover in the in-depth videos. This is for the introduction part, and this will be covered in a very in-depth fashion in the tutorials. Thank you for watching this video.